Thank you, Tobias. So I will be speaking about visualization of temporal origin destination data. Just to briefly introduce myself, my name is Bergen. I'm from Russia. As you can probably guess by the look of my head, maybe. I work in Switzerland. My supervisors are Denis Lalande and Enrico Bertini. And for this work, we collaborated with Peter Bach. Hello. So I will be speaking about origin destination data. What is it? Origin destination data represents interactions between pairs of geographical locations, like something moves from A to B, or there is network traffic from A to B, or A sends money to B. Basically, it's a directed graph. There is a set of nodes, which are geographic locations, and a set of flows, or edges. And each flow consists of the origin node, destination node, and magnitude. The magnitude may change over time. So in this case, we have temporal origin destination data. And there are lots and lots of data sets in this form. Our project began as a collaboration with the UN. So we decided to visualize the refugee data set, which is collected by the UN Refugee Agency. And it's a typical example of origin destination data. It represents numbers of refugees coming from different countries to find asylum in other countries. There's data for more than 34 years. It's not a very large data set, but it's still challenging to make a meaningful visualization. And this data set can tell stories about millions of people who have to leave their homes and find refuge in another country every year. So they work with this data at the UN. What kind of charts do they use to represent it? They publish reports, including all this data every year. And these are the charts from the latest report, actually. So they use bar charts to represent major origin and destination countries of the refugees. They use coordinate maps or bubbles placed over a world map to represent refugee population of different countries. And they use time series to show change over time of the total numbers of refugees in the world. So all these are really very good graphs, perfectly suited for showing summaries in a printed report. Why do we need something else? The problem is that they are separate from each other. Each of them only concentrates on one single aspect, either the origins, either destinations, or time. And each of them shows only a summary of the data and doesn't allow to explore the relationships between the origins, destinations, and time in detail. How would we find, for example, by using these graphs, that there was a huge increase in the number of refugees from Myanmar to Bangladesh in 1992? We probably wouldn't, because this information is buried somewhere in the summary. And even if they were interactive and would allow to form queries or use a filter, it would still be difficult to use them for detailed analysis and exploration because they are separate from each other. So for us, the challenge is in bringing the available tools for the analysis of origin, destinations, and time together in some elegant way, which would allow us to explore the data in detail and make findings taking all these three aspects into account. There is an approach which is widely used and has been known for a long time for representing origins and destinations. It's a flow maps, which show entities moving between locations by drawing them as lines connecting the locations on a geographic map. This is an early flow map of world's migrations made by Mina, and it's a very good one. But here, notice that representing the paths of migrations is not the goal. The goal is to show on the map how much is flowing, where it is flowing from, and where it is flowing to. So it's really about O's and D's, origins and destinations. So we first represented the refugee data on a flow map. This is how the data for 2008 looks like. Here we used color markers to represent flow directions. Red stands for outgoing, green for incoming. and we used the width of the edges also to represent the magnitudes of the flow. So how many people? So the largest flows are more thick. And yeah, it works to some extent, but flow maps in general suffer from visual clutter caused by multiple line intersections. And actually there is a lot of research which is trying to address this issue. For instance, edge bundling. So here we implemented one of the algorithms. But it's not what we are after, actually. We want to be able to visualize and explore temporal dimension along with the origins and destinations, and not just to improve the quality of the flow map. Could we somehow embed temporal data into a flow map without adding even more clutter? So that's what we are after. We want the tool which we developed to help users to answer questions involving origins, destinations, and time, like when and where were the largest flows, and where means here both where did they originate and where did they go to. When and where there were significant changes. How did the flows of specific locations change over time? And how similar are the changes over time of the flows of two specific locations? This is just a few examples. In the paper we have more actually, questions which we address. We borrowed some ideas, many actually, but this one is important. This is an example of semantic substrates proposed by Schneiderman and Aries, which the goal is to support interactive graph exploration of complex graphs. And the basic idea is that you have separate views which show different aspects of the same elements, and then you show connections between them as links across the views. So this is an important idea. Here you see, for instance, telephone calls, and in the bottom view, they are positioned according to their duration. The longest are below, and in the upper view in the map, they are positioned according to places where they were made. And then you see 3 longest calls are selected, and then you see the connections where they are on the map. Another source of inspiration for us was the nature itself. This is strata, rock layers, which you can probably see as horizontal layers, which have different geological structure and correspond to different time periods. And geologists deal with dating such rock layers. We will do something similar to represent changes over time. So here you see, for us it is not necessary to show the exact paths of the flows. It's not important for our task. And it's not even known which routes the refugees took. So we can reroute the flows in any way. We can even use 2 maps, one for the origins and one for the destinations. And then we can put the temporal information in an abstract view. We chose heat map, but in fact it doesn't have to be a heat map. In this heat map, columns represent the time dimension, years, and the so-called colors, the flow magnitudes. Each row corresponds to one flow, and you can see by the changing color in each row, you can see how the magnitude of this flow changed over time. And we draw flow lines so that they connect the flow origins and destinations with the corresponding rows of the heat map. So this is Flowstrates. What's good about the fact that the origins and destinations are 2 separate maps? One of the things is that this way we can clearly show the flow directions, which is not always obvious in cluttered flow maps. So you know that this is origins, these are destinations. We can also potentially use other appropriate representations for temporal data. It doesn't have to be a heat map. It could be a horizon graph or time series or 2-tone pseudo-color. And we are not constrained by having to fit this temporal representation into a map. can also use geographic maps to show some values. And we can even use the same color scale for the heat map and for the maps. So here you see, which shows, we selected year 2001 in the heat map. And now we show the aggregated values. In the left map, we show total outgoing flows, magnitudes of the flows, numbers of people who left countries. And in the right map, in the destinations map, we show total incomings, incoming magnitudes. And we can just use the same color scale as in the heat map and compare the values. Yeah, so now I hope to show you a short demo, if it works. Okay, it looks good. So this is our prototype implementation. The heat map, the maps, we can zoom and pan independently. We can click on a cell, and then we are moving to the countries, corresponding origins and destinations, and we can scroll. This heat map is actually long, pretty long. We can scroll it, or we can look at the whole. This is not very useful because there are too many flows, 6,000. But fortunately, we can sort the rows of the heat map, or we can group them in some way. So here we group them by origin. So this is now the whole data set, and each row corresponds to a single country, and we show aggregated values for countries. So, and in the maps, we show then values for each specific country. So now I chose Afghanistan, and in the destinations map, we see all the totals, how many people from Afghanistan are in all those countries. It's shown with the color. So let's go back to the original view of the with all the flows. And yeah, let's select in the maps. We can select some region or some country, and let's select the same region here. And now in the heat map, we see only flows between those countries which we selected. And yeah, there is also one feature which I want to show. It's the flow lines. We can show them all. You don't see them that well, but the idea is that we can reorder the rows of the heat map so that flows from the same origins are put together. So here I selected Sudan, and all the flows from Sudan are close together in the heat map. And by color coding, we just give the user the hint where in the heat map are the countries which he selected. But we can do it only, unfortunately, on one side, either origins or destinations. So if we want to do the same thing for the destinations, we have to change the sorting of the heat map, of course. You can see, for instance, that there was a lot happening with the flows to Sudan, right? So there were a lot of people who went to Sudan, refugees. And there were also a lot of people who left Sudan as refugees and went to other countries at the same time. So this is strange, right? And we can see the same thing if we select. So if we select a year in the heat map, we can show in the maps the totals for these countries, for these flows, which we selected actually. And we see that there were a lot of refugees from Sudan. It's the big country in the middle. And many refugees went to Sudan as well. It's also dark red in the destinations map. And let's explore it in more detail. So we select Sudan, and now we see only flows from Sudan to those countries which we selected. And here we can basically see what was happening with the temporal, how the numbers of refugees were changing. So here we see that there were a lot of refugees to Ethiopia from Sudan until 1999. Then the number decreased slowly. So I will make it bigger. The number decreased a lot actually here, by 300,000 people. But still it was augmenting slowly. And in 2003, there was a big flow, growing number of people who went to Chad from Sudan. Okay, we can also look at the refugees who went to Sudan. So there were many people who left Sudan because it was so bad, but even if it was that bad in Sudan, many people came to Sudan from other countries, so it was even worse there, probably. And we can see that there were a lot of refugees from Ethiopia until 1991. Then the number started to decrease. And then many people came from Eritrea. Actually, here there was no data, so we just have data beginning with 1999. We don't really know what was before, but unfortunately. But we know that in 1999 there were 500,000 people, refugees from Eritrea in Sudan. And we know what was happening afterwards. Yeah, actually in 1991 the 30-year-long war ended between Eritrea and, so it was an Eritrean independence war from Ethiopia. So it might have affected this. Also the fact that there was no data for previous years. Yeah, we can also visualize the differences using another color scale. Here blue means the number reduced and red means that it increased. So we can see that numbers of refugees from Ethiopia were increasing in these 3 years, and then they were slowly decreasing. Mostly, but not in all of the years. So, in the latter years, most refugees were from Eritrea. Let's look at Eritrea itself. Where else did people go except for Sudan? So if we sort by 299, so I just sorted by this column which I selected, we can see that most of them went to Sudan, many went to Ethiopia, some went to Israel, probably crossing the Red Sea or the desert in Sudan, and many also went to Italy. This is where the smugglers bring them in their lousy boats. So, yeah, I think you've got the impression of how it works, how you can make findings by interactively exploring this data and see some things which are hidden in aggregates, because when you just see a time series graph in which it is said that there were 5 million or 12 million refugees in the world in 2001, it doesn't tell you really much. So, there are some limitations. You probably saw some of them already. Flow lines are not realistic because the directions and the lengths are not really realistic. Even in some cases, if there is a flow between two neighbor countries, we have to reroute it to pass through the heat map, and this is not really realistic. But in fact, this is the case for most of flow maps, because the addressed tasks are not concerned with exact flow routes. If you need to visualize exact flow routes, you are better with another technique. Also, the vertical space is limited. As you saw, we have many flows. Not that many actually, but we cannot fit them all in this view. But the fact that we use an abstract representation for the temporal data is actually something that makes it really simple to reorder and regroup the rows. And use some aggregation techniques. And we are not constrained by the map. Also, if we show all of the lines, for all of the flows. There are too many crossings and occlusion caused by them. But in fact, we don't have to show them all of the time. The flow lines are only useful when we highlight the flow between two countries or a selection of countries. Or when we want to group the flows, as I showed you before, by their origin and destination. And then we see which parts of the heat map correspond to which origins. So for the future work, we want to do many things. Try other temporal representations, time series harassment plots, two-tone pseudo-colors. Add some intelligence and data mining techniques which would help us to find interesting or group similar flows and reduce the size of the heat map. We would also like to improve, to make the UI more intuitive and the interaction more smooth. Because to validate the approach, we want broader adoption, which is the best way to validate a technique, as I think. And this would allow us to gather some feedback. I mentioned our collaboration with the UN at the beginning, and so you might ask whether we have some feedback from them. Unfortunately, this tool is not used by the UN, and our collaboration didn't work that well. We were only collaborating with an IT department, not with the department working with refugee data. And as we tried to contact some analysts at the refugee department, our partners blocked it. They were not interested in it. Apparently they just wanted us to help to develop their software and not really to visualize something. So, yeah. But it looks good anyway, because I've been contacted by about a dozen of people who discovered the project website, and so they wrote me that they have used already or plan to use the tool to visualize very different data sets, labor migration in Chile and Australia, trade flows, and in Louisiana, even scientific collaborations across the globe. So there is some interest in the tool, and I think we have good prospects in terms of adoption. That's all I wanted to say today, so thank you for your attention. I'm looking forward to your questions.
Yes, thank you, Ilya, for your presentation. We have time for a few questions. So if you have questions, the microphone is open. If there are no questions, I would have one. So you use land covering maps on your left-hand, the right-hand side. And you have one application example in your paper, which is commuting streams between cities. And I was wondering whether you may want to overlay also the transportation network on your maps to give individual additional hints on the sources of those flows. Have you thought about this?
Yeah, it would totally make sense, sure. Laying the data over different kinds of maps. Because for instance, for refugee flows, you would like to know, is it a desert or is it a sea between two countries, for instance? It would give a good hint, yeah, sure.
I also saw in your presentation that you preferred to show migration between east and west. And naturally, this is where your tool performs the best. Would it be possible to kind of implement some flipping of this axis in between when you want to show north-south migration as well?
You mean from
for instance,
Europe
Africa to Europe or the other way? Yeah.
From Africa, of course it's possible, because these two maps are, you can pan and zoom them independently completely.
Yes, I know that, but I mean the flow lines makes more sense when they go from east to west. Is it? The design choice? Is it like a very different performance in the one or the other?
I wouldn't say so, because as I said before, it doesn't matter how the flow routes look like for many applications, not for all, of course.
Yeah, but you're actually right.
Yeah, the idea here is to show where they go, where they come from, where they go to, and what was the temporal development. So
thank you.
One last question.
Thank you very much. I'm impressed what you have done in the past. Yeah? My question is, I mean, you are dealing with quantitative data, yeah? And your heat map primarily shows tendencies. Yeah? Don't you think you need to also to show the people or the analysts how it really changed? Yeah?
You mean the differences?
Yeah.
Yeah, yeah.
I mean, you have this in the qualitative sense, yeah? But if you want to compare this?
You mean
So just to combine
the
different
form
kind
of the curve?
Yeah.
Yes, this is where probably data mining techniques would help, right? To find some similar flows, similar behaviors for some countries. Yes, this is
Shapes and
yes, similar shapes. Yeah, that makes sense.
Very good. So let's thank the speaker again. And we're about to move to the second presentation in this session. The title of the next work is Temporal Visualization of Boundary-Based Geoinformation Using Radial Projection. This